Hello everyone, let's talk about probability. Probability plays an important role in statistics. It is the foundation of inferential statistics, which involves making generalizations about unknown population parameters. Okay, let's get started. After watching the movie God of Gamblers, Mr. Imaginary claims that he can also hear what a die shows when it's rolled under a cup. So Mr. Pie has decided to roll a die using a cup 6 times. And we'll find out if Mr. Imaginary can tell the number of the die correctly. So here are a few questions that we can ask. How do we tell if Mr. Imaginary is guessing? In other words, is he just imagining that he has super ability of hearing dice? How many correct answers does Mr. Imaginary must have to convince us? How likely can Mr. Imaginary guess all 6 out of 6 correctly? With probability, we can answer all these questions. Before we see what happens, let's talk about some basics of probability. Consider a procedure or experiment of rolling a fair die. The possible results are 1, 2, 3, 4, 5, and 6. Each of this is called an outcome, and any collection of the outcomes is called an event. A simple event is one that can be broken down into simpler events. For example, an outcome of 4 is a simple event. But an outcome of an even number is not simple because it can be broken into 3 simple events of 2, 4, and 6. When we want to refer to all possible outcomes, we use the sample space. For example, the sample space of rolling a die is the set of all 6 numbers, with each separated by a comma. Here's another example. The sample space of flipping a fair coin is the set of the 2 outcomes head and tail. If we combine rolling a die and flipping a coin as one procedure, then there are 12 outcomes in the sample space, as you can see here. So what is probability? There are different interpretations, and we'll talk about 2 that's often discussed in introductory statistics: classical and relative frequency approaches. In classical approach, probability is expressed as the ratio of number of ways an event occurs to the number of different simple events that are equally likely to occur. The relative frequency approach says that the probability of an event can be approximated by the relative frequency of the event when the procedure is repeated many times. So, using the relative frequency, we can approximate the probability of an event occurring. We count the number of times the event occurs and divide it by the number of times the procedure is repeated. Since the number of times an event occurring cannot be larger than the number of times the procedure is repeated, the probability of an event cannot be greater than 1. So probabilities can only be numbers from 0 to 1. A probability of 1 means that the event always happens, and a probability of 0 means that the event can never happen. Before we move on to talk about finding probability, we'll introduce some symbolic notations, which will make it easier for us to talk about probability. The capital letter P stands for probability. The letter A inside the parentheses is the name of a specific event. This expression P of A is the probability of the event A occurring. So now, we are flipping a fair coin and let H be the event of getting ahead. To find the probability of getting ahead, P of H, we simply take the number of times H can occur and divide it by the total number of different simple events. So the answer is 1 over 2. Let's roll a fair die this time. Let A be the event of getting an even number. Then to find the probability of getting an even number, we take how many even numbers there are and divide that by the total number of outcomes when rolling a die. So the answer is 3 out of 6, which is equal to 1/2. How about drawing cards? We all know that there are 4 suits in a deck of 52 cards with 13 cards in each suit. Let's see the event of drawing a club suit. For the probability of drawing a club suit from a deck, we first find that there are 13 club suits in a deck, and then find that there are 52 cards in the deck, and divide them. So we get 1/4. Now, what about using the relative frequency approximation? Let's say a quality control manager is doing testing on a delicate component of a machine from a batch of 500 units. He found that exactly 36 are defective. That means there are 464 units that are non-defective. So, if we randomly select a unit, the probability of getting a bad one is 464 divided by 500, which is 7.2%. Okay, let's get back to testing Mr. Imaginary super hearing ability. We'll do more probability next time. Stay tuned. Please subscribe and give me a like to show your support. I'm Wilson. Thank you for watching. See you next time.